Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Welcome to the afternoon session. This is a session titled Augmented Reality, Perspectives from Industry and Academia. My name is Hrvoje Benko. I'm a researcher here at Microsoft Research. My research actually covers some of the augmented reality parts, but I also do a lot of kind of interactive graphics, 3D user interfaces, spatial augmented reality, etc. I work here with Andy Wilson on lots of fun different projects. But today, I'm happy to chair the session on augmented reality. Let me start with the definition. There's lots of disputes about and discussion about what exactly augmented reality is. I like to use the definition suggested by Ron Azuma, which basically augmented reality combines media from real world, virtual media and the real world. It's a real-time and interactive experience, and it's spatially registered. And this last one is the one that oftentimes is a sticky point to folks, but really what it means is that there's a tight coupling between the virtual media and the real world. Now, for most people, when you say augmented reality, they have a picture something like this. This is from 1984 Terminator movie, a long time ago, right? And it's tightly coupled, integrated, real-time interactive and spatially registered, mixes of real and virtual, right? So it does fit the bill. And while there's been lots of work, especially in the early 90s, of trying to actually recreate some of these experiences, really kind of tightly coupled. This is a picture on Columbia campus, one of the early work from Steve Feiner. And to actually create experiences like this, most of the experiences, most of the folks that actually experience augmented reality on a day-to-day basis actually look at it like this. This is the yellow first down line in football, and there's nothing. It's just very different than the experience that the early pioneers kind of set out to accomplish. The other form factor that people are really used to these days is augmented reality on smartphones. So this is basically looking at video see-through display, taking a video and overlaying augmented virtual information directly onto the real world. Now, as much as these are permeating right now, and there's lots of different applications and lots of different startups, companies are actually starting to push these ideas, I don't really believe that they've actually hit mainstream. Even the folks who have these applications installed, there's not much actually uptake in its use. Maybe it will be, but right now we're still kind of waiting for the widespread adoption. So I always get reminded by my colleague Bill Buxton, who is also at Microsoft Research, that any technology adoption takes a long time. And just to illustrate this point, I'm going to say, for example, if you were here in the previous talk, you've seen probably an image similar like this. And this is a mouse demonstrated by Doug Engelbart in 1968. And adoption took till Apple's, the widespread adoption basically took about 15 years. Sorry, 15 years to get from the first demo to actually widespread adoption. Similarly, with multi-touch, right now all the rave is it's touch and multi-touch gestures. We saw a session on NUI right before. Some of the early work happened in the 80s, early 80s, and the adoption, the widespread adoption, I guess one could argue, it really began with an iPhone in 2007. So again, the technology adoption was 24 years. But this is actually really encouraging to me. So about 15 to 24 years, sweet spot might be around 20. So some of the early work on augmented reality, I mean, one can argue Ivan Sutherland did some augmented reality way early on, but some of the really kind of beginning of the field really in a widespread kind of research began in the early 90s. This is a work of Feiner and Shamash in 91, and in 2012 we are about we've seen something like this from Google. This is Google Glass. Now, I'm not completely sure that this is actually augmented reality, but at least it pushes the idea out into the mainstream right now. And the spread is about 21 years, so we're right in the ballpark potentially of seeing something that might actually inspire a widespread adoption of augmented reality. So to tell us their perspective and to tell us kind of what the challenges that are actually working on and what their perspective on the field is, I've invited three very luminary speakers to tell us their story. And the selection criteria for actually being invited is that they have a funky picture of themselves somewhere on the internet. So all three fit the bill perfectly, to the T, actually. So each one has a separate story in this case. And at this point, I don't want to do any more introductions. I'm going to actually introduce Steve Feiner, who's going to talk about who's going to talk first. But before we go there, the way that I've envisioned this session going is each speaker will have about 20 minutes to give their talk, to talk about their experiences and their vision for the future. But then I really would like to invite everybody in the audience to participate. I'd really like this to be more of a dialogue than a particular lecture-style discussion. So we'll all kind of sit out front and hopefully answer some of the questions. So at this point, At this point, I'd like to introduce Steve Feiner. He's a professor at Columbia University, where he directs computer graphics and user interfaces lab. This is actually the lab that I got my PhD in, so I'm very fond of Steve's work. His lab created the first outdoor mobile augmented reality system that used see-through head-worn display back in 1996. And the lab also pioneered experimental applications of augmented reality to applications such as tourism, journalism, maintenance and repair, and construction. Steve received his PhD from Brown University, where he studied with Andy Van Dam, and he's a co-author of several different books. Probably the best one known is the Computer Graphics Principles and Practice, as well as recipient of many awards and newly elected into Chi Academy, not newly elected, but elected into Chi Academy. So please welcome Steve Feiner. Oh.
Hey, let's see if we can switch over. I'm not sure how to do this,
Here.
actually. You could do that. Oops. Oh, it's adjusting. Good. Great. Okay. Thank you. So in keeping with Benko's discussion of history, I'm going to push things back a little bit further to where they really belong, which is over 45 years ago to Ivan Sutherland's pioneering work on head-tracked VR and AR. 1968 was the first publication. If you compare that with, for example, the mouse from '68, which got into real products a whole lot earlier than we're seeing AR get into real products, one could maybe argue that, wonderful though the mouse is, it's a lot easier technology than to go and get all the things right that one needs to get right to do AR really, really well. So 45 years counting from before the publication of that paper to today, we're still nowhere near really being there yet. 16 years ago, we decided in my lab that it was hard enough to do this stuff indoors. Let's try to do it outside. And we did it with 45 pounds worth of crazy stuff in a backpack. This is, I think, our second or third generation with Benko before I managed to give him some of his current gray hair. In this case, a restaurant guide that we did for the EZAR conference in New York in 2001. Outdoor little map application in which you can see a little world in miniature in front of you. And some buildings no longer in existence from the history of Columbia's campus being able to be visualized around you as you walk around. So there's lots and lots of really cool things one can do outdoors and indoors. And in fact, we can even do things like, for example, put a variety of different kinds of visualizations of things that are more abstract than buildings. In this case, some work by Sean White showing by their height in these colored spheres carbon monoxide concentrations at locations around you. And of course, games. There's so many applications in pretty much every aspect of computer science technology to making things that are really fun and enjoyable to do. And AR is certainly no exception. So one thing I did want to concentrate on, besides going cursorily over some of these application areas, is one that's rather dear to me, and that is AR for task assistance. So how can we use augmented reality to be able to overlay directly on what you're seeing in the environment instructions that help you do stuff in that environment? In this case, we have a young Marine who is a subject in one of the studies that we did using AR to be instructed how to find various places in the environment of a very tightly enclosed light armored vehicle turret, and comparing this with how one might find that those places using more classical kind of documentation. So this is a still from some of the stuff that we did, and what I want to do now is to show you a little video to give you an idea of what AR documentation might look like in comparison with more classical kind of paper-based documentation or documentation presented on, let's say, a laptop, as modern military documentation is. So what we're going to see here is some documentation that explains to a person through overlaid graphics how to find a particular combustion chamber part of a aircraft engine, and then pick it up, orient it the right way, and insert it into the engine itself. We're lucky because my former student, Steve Henderson, whose work this is, spent some time right before he started with me refurbishing with his family an aircraft engine that we have sitting in the corner of our lab. So let's see what that looks like. So we have a little red arrow that's pointing to where the combustion chamber is. And now we're given instructions to go and pick it up. We have some markers on it that are telling the position and orientation. And the system is now giving you a little arrow that's indicating you're supposed to turn it in the direction of the arrow. Now we have a little placard. Well, you know how to read. You should make it so it's right side up. And when we have it right side up, then the system knows that, and we can therefore go over and put it into the engine where it belongs, a little ghost overlay of where it's supposed to go. So you might say, gee, that's really cool looking, but you know, is that actually useful? Is this better than more conventional kinds of documentation? So that was an important question that we, in a study I'm going to tell you a little bit about, tried to answer. And so we had a task. The task was to assemble one of these combustion chambers. And it turns out the combustion chamber is made up of two major pieces: a bottom piece, which you're seeing up there, a top piece that you're seeing at the bottom. We had 3 each of the bottoms and 3 each of the tops, each a little bit different actually physically. So you've got to get the right bottom, the right top, then you have to orient them the right way, lining up the right one of the 20 holes in the flanges on the top piece with the right one of the 20 holes in the flanges on the bottom piece. And so you're seeing off on the right the experimental layout with little bins, every part in its correct place, a little turntable in which you're going to put a bottom and then a top on top of it. And there's actually a big red kind of idiot button that you use to start and stop the experiment. And then, of course, we're tracking each of the pieces using standard motion capture tracking technology. So we know exactly its position and its orientation, so we really know whether you picked up the right piece, whether you're putting it in the right place, etc. So I'll tell you a little bit about a study that we did to try to explore this problem. This is a within-subject study, so each one of the participants did things both with the AR documentation that I'll show you, and as well also an LCD-based documentation, which you're seeing on the right-hand side over there, which is presented on a nice-sized flat panel display. And we've put quite a lot of effort into trying to make this into really good LCD-based documentation in comparison with what's actually used in the military, more classically displayed on a smaller notebook display than this larger LCD. So the idea was to pick the right bottom, the right top, and then line them up correctly. So in the AR documentation, I'll show you a little video. It's going to go by fairly quickly. And I want to point out some of the things that we were doing. Essentially, we were throwing in kind of like everything but the kitchen sink in terms of the various kinds of overlays. Arguably overkill, but that's not something we were worried about at this point. So we had, for example, little highlights you're seeing in these stills over here indicating the right destination and source bins. The little sort of stylized motion path, that little blue arc showing the source and destination of a particular piece that you're going to be moving. We had prescriptive 3D arrows. Once you've got a part, a top part on top of the right bottom part, and the system actually will stop and make you put back a part if you've got the wrong piece in your hand. There's these arrows that you're seeing. The further away the lettered hole at the top is from the appropriate matching numbered hole at the bottom over there. The longer the arrow will be, the redder it will be. It goes through red, through yellow, through green, and finally disappears. And on the right, in fact, you're seeing what happens if you actually overturn it a little bit. You go past where you're supposed to line up, and then it goes back to now being green. And if you did it even worse, it would be yellow or red, etc. And little alignment highlights. Here we have a little zoom in here with these little highlights above the left, rather top and bottom holes. And then when they line up, they merge into one, and you put a little pin into the hole. In the real test, there are actually 20 bolts that would go in, but once they're lined up, there's really no assistance that a person who knows how to use tools is really going to need to get the bolts in all of those 20 holes. So we wanted to make the experiment really concentrate on just getting the right top, the right bottom, and lining them up correctly. So I'll show you a little video of what this looks like. We're using what's called an optical see-through display, which means that the combination of the real world and the virtual world is done using basically lenses and mirrors. And that means that you're going to see the combined image courtesy of having this configuration be close to your eye and you're looking through it. And there's really no room for a camera, so the video that I'm going to show you is actually done using an optical see-through display. We put a camera inside of the eye socket of a dummy head, put the display on the dummy head, and to make this particular video, we have one grad student holding the head and moving it around, another one basically reaching around the outside like that to be able to make it. Of course, really you'd be wearing it, but we didn't want to go and do violence to our graduate students by putting cameras inside of their eyes. So let's see what this looks like. There's some audio to this, so let's hope that the audio is going to be playing. So you're seeing one of those red arrows like I showed you before. It's pointing to the bin with the lower bottom that you need, a little highlight over there pointing down to the Lazy Susan that you put it on top of. The system is tracking position and orientation so it knows what thing you need to do next once you've actually done the task. Now we put the top on reasonably close. It's yellow right now. And so person grabs hold of the top and bottom, moves them together, it goes to green, the arrow disappears. And then we put the pins in. And then hit the button. So the question is this actually better? Well, we ended up doing a study with 22 participants, and based on some hypotheses that we came up with in an earlier pilot study, we were able to show that AR was, in fact, definitely faster, significantly faster for the alignment and pinning, taking a little bit more than half the amount of time that it took to do this with what I think we're quite proud to say is really good LCD-based documentation. It was more accurate. This is a relatively hard task to do, especially when the documentation isn't actually overlaid directly on the stuff that's documented. The tops and bottoms differ only a little bit from each other, and in order to line up the right holes, the holes themselves don't really say what they are on the device. You have to use landmarks, and that can be kind of tricky. And so people did significantly better in terms of accuracy, getting within a half hole width of the right hole, where the final last teeny tiny bit of reorientation gets accomplished as you actually put the pin in. And as well, in a post hoc questionnaire, the participants overwhelmingly preferred and thought more intuitive the AR condition rather than the LCD condition. So what I want to do, having talked in a little bit of detail about that particular application area, which I think is a really important one, I want to talk a little bit about some of the research directions that I see for augmented reality in general. 45 years since Ivan Sutherland's work, and there's many, many, many years worth of, I think, important research left to do. One of them is, as Benko mentioned, a lot of the apps that you can buy right now, in the App Store on whatever your phone is are apps that basically are designed for this handheld mentality. I'm holding in my hand anything from the large tablet that you're seeing at the upper left, some earlier research work that my lab is doing, to a bunch of these commercial apps that you're seeing off on the sides over there for a variety of different smartphones. And we've got this model basically of I've got this thing, I've got to pull it out of my pocket or holster, I've got to turn it on because it's usually not kept stored on. I might have to turn on the GPS because maybe I don't leave it on because my phone battery will die if I do. I've got to hold the thing out at arm's length so I can actually comfortably look at the screen. And this takes a lot of effort and time. And it's just not something that I think is particularly natural or comfortable or necessarily desirable. So how do you overcome something like this? Well, make it so that you can see the real world and overlaid stuff without having to hold the display and hold the camera in your hand itself. And, well, that's eyewear. And I'm showing you here a little picture, a part of a slide that I first used back around a little more than 10 years ago. It's a picture of Benko, back when he was my student. And basically, he's wearing one of our backpack systems. And I had these little red PowerPoint X's over the big stupid antenna, the big stupid backpack, the rather, although it was optical see-through, it was very dark, sunglassy-like, and uncomfortable head-worn display. The largish forerunner of a smartphone in a kind of pre-tablet PC tablet that he's holding over there. All of these things clearly needed to get smaller and better in a lot of different ways. Now, the neat thing is that if you could actually have made a really good display back then, I don't think it would have taken off because it needed to have the right milieu. If you had a wonderful display from the future being magically transported in the time machine back to 2000 or back to the late 90s, what are you going to hook it up to? What's going to drive it? Where's the content? Okay? How are you going to go and do the tracking in a relatively lightweight kind of way? All those other things didn't really exist. And the really cool thing right now is we've got very powerful computers that we call smartphones. We have huge quantities of content. We have a way of getting the content to the phone. And so a lot of these things are very different than they were before. So what's eyewear going to be like? Well, this is an example of an optical see-through display that my lab and a number of other labs uses right now. This is made by a little company called Enviz. 60-degree diagonal field of view, 1280 by 1024 stereo resolution. But it's big, it's bulky, weighs over a kilogram, rather expensive. And I think normal people are not going to want to, even a geek is not going to want to walk around literally with a kilogram worth of stuff in their head, okay, blocking them from the real world, even if you can actually see through it, and you can. This is rather transparent. So this is certainly not it. And now we look at something like this, okay? I think the industrial design is rather nice on this, but it's a little teeny tiny display. It's not in your direct field of view. It's sitting up at the top with a little camera in it, admittedly. This is very nice, I think, in terms of wearable computing, but this is not augmented reality. This is not something that's going to be overlaying registered material on the environment around you. And in fact, if you look at things like this, over 10 years before, literally late last century, this is a Micro-Optical Corporation clip-on, which was actually a commercial product sold into a very, very niche audience. There's the IBM Vision Pad over there with, again, a very small little one-eye display like you're seeing. These are things that didn't really take off because, well, what would you use them for? They didn't really have the right environment to be able to take off. And while they were trying to make, in fact, made a computer that you're seeing being held off in the lower right over there, that was a research computer, not really something that you could make affordably back then. Needless to say, eclipsed in every possible way by a modern smartphone. So while this, I think, is a neat model for wearable computing, it's not augmented reality. Now we're getting a little warmer. These are actual products right now from Epson at the top, from Vuzix at the bottom over there. They are optical see-through. They're somewhat bulky, not as bad looking as that very, very big but wider field of view display I showed you before. But normally, you're not going to walk around outside like that. I mean, that's a little bit geekier, I think, than even really geeky people want to actually look. So here we're getting, I think, a whole lot warmer. So there's a display by Loomis that you're seeing at the top over there, a little Israeli company. A experimental display by Sony at the bottom. You might recognize that as Tom Hanks, who was wearing it during a CES keynote that he participated in that Sony gave a couple of years ago. These things look like eyewear. They might look like geeky eyewear, but the really neat thing is that while these are really designed by engineers, I think a really talented industrial designer could take this kind of set of constraints and make something that would really be an object of desire, that would make people who didn't have one feel like they really wanted to get one just because they wanted to look cool. Okay? And this stuff is makeable right now, but the question is, can you make it in enough quantity? Can you make it without having to do a lot of handwork? Can you make it enough quantity to be able to go and sell it at a reasonable price? That's really not something that you necessarily would want to bank on right now. So we're going to see things that will be descendants of stuff like this that will actually be affordable and that will actually be something that people will really want to wear. So let's say we had that millennial display, that really wonderful eyewear. Well, although I really believe that we're going to have stuff like that at some point in the future, I don't think that all the other displays in the world are going to go away. I think there's many reasons to want to have displays that are stationary, that are large, that are small, that are handheld, in addition to ones that are wearable. And so this is a little work that my lab is doing on combining eyewear, rather bulky eyewear right now, admittedly, with other displays. In this case, combining a Microsoft Surface, a rear-projected horizontal tabletop, showing, in this application, footprints of buildings. So anyone can walk up to it. They don't have to wear anything special. And they can see, basically, the building footprints on a model of the Earth. But if you're wearing eyewear, you can see the buildings actually erected above the footprints and essentially violating the bezel of the display. So even if the Microsoft Surface were stereo, it can't make things that essentially are not going to be cut off literally by the bezel when you look at it at an angle. So this is work by Nick Dedwall. And here we see some models courtesy of Microsoft of buildings in downtown Manhattan. There's a Flatiron building over there. And then as we interact with the surface, we can scale and rotate and translate and all that other kind of good stuff. And the buildings basically are going to be following as we do that. And in this case, we have some information being displayed on labels on the side of the building about things that live in those buildings, and then the ability to also throw in a Windows Phone over here, which has a little occluding volume around it so you can actually see it, even though you're wearing the head-worn display, and then be able to go and interact with information, and when you find something of interest, be able to go and find out more information about it. So another important, very, very important research direction, and that's that AR is very different in many ways from classical user interfaces. Classically, our user interface basically is as featureless as possible, as black as possible rectangle in which we can control every single individual pixel. You know, and that's just really nice for a designer. They can have complete control. Okay? In AR, by definition, you're combining with the real world, and that means you can't control the things in the real world necessarily. In many cases, not at all. And therefore, if you want to overlay stuff visually or overlay stuff sonically or appeal to any other sense, you have to make things that respect the things that you're actually experiencing in the world around you. So we need systems that can either be told in advance about certain things that are predictable, like let's say models of buildings, but also can sense and perceive in the world where it might be too bright, let's say, to overlay something, or too complex in terms of detail where to overlay something. So that we can create experiences in which we don't overlay something that we really want to see with information that's obscuring us from it. Okay? Something very, very important. You need to sense, you need to know what's out there so you respect it and you work with it rather than working against it. Education. You know, these are new kinds of interfaces. And so not only do we have to come up with new ways of designing for it, but we also have to teach people about how to do stuff. I've been teaching a course for the past around 6 years now on 3D user interfaces. A couple of years ago, I decided I would actually go public with the emphasis on augmented reality. I actually added augmented reality to the course name. Over the past semester, we did it for the first time with smartphones through a generous gift from Nokia of a set of Lumia 800s. And so you're seeing over here an application running on one of the phones that a student group did. And on the left, you're seeing a stereo viewer, which Mark Bolas's MXR lab developed, that Mark was generous enough to give us a bunch of to use in the course. And he's going to tell you more about that when he speaks. Finally, one last thing I want to say, hopefully I have enough time to say it, and that's that I think there's a lot of really fascinating and sometimes maybe a bit scary set of problems that are raised by the idea of having the kinds of sensors that we need to do this kind of augmented reality. We're going to be wearing, everyone ultimately perhaps will be wearing, or most people will be wearing, a variety of sensors, very high resolution, very high quality, very high dynamic range, very sensitive in terms of audio sensors, massively walking around. And imagine getting that data, streaming it from the people walking around, searching through it, matching it, storing it in a variety of places, the same way we store stuff that's out on the web right now. And all of that data, of course, is going to be time-stamped very, very precisely, geo-referenced ultimately very, very precisely. And there's a lot of things that, well, you might argue you have no right to privacy for, since you do them in public. And yet somehow you think of them as being fleeting and disappearing. It's not like you actually posted your picture on Facebook, for example, and then you can't get rid of it. You just walked around outside. But imagine that the stuff that you did is being captured by other people looking at you, by other people watching you, by other people sensing you as they're walking around. And all that's time-stamped and geo-referenced, so you can put together individual pictures, individual videos, individual sonic snippets captured by many, many different people and make coherent streams through people's lives who passed by many, many people on the way to going to work, for example, and yet you can follow their every move as they're walking. Very, very frightening, I think, and I really can't think of any way around that in terms of current laws. So at this point, I want to conclude, acknowledge many former and present students and colleagues who participated in the work, and I think turn it over back to Benko.
Thanks, Steve. And Mark, if you can just come up and set up. So I think we should just, we're running a little bit behind, so I think we should just hold off on some questions, and hopefully there'll be some time at the end to have all the questions. Next, I would like to announce to you Mark Bolas, who is Associate Director of MXR Lab at the Institute of Creative Technologies down in University of Southern California. And his work focuses on creating virtual environments and transducers that fully engage one's perception and cognition in the visual, to create a visceral experience. Mark completed his thesis at Stanford University, and he's also the chairman and co-founder of FakeSpace Labs, which builds instrumentation for research labs to explore virtual reality. He's a recipient of many awards, and the IEEE Virtual Reality Technical Achievement Award in 2005. So looking forward to your talk.
Thank you, Benko.
Yeah. Do you know how to, should we switch this?
I do. I think it's number 5. It is. And the mic's working okay back there? Okie doke. How many people know the concept of impedance matching? You take a rope, right. The first time I heard it, it's just the sexiest concept there is. You have a medium like a heavy rope, you have a medium like a thin rope, you tie them together, you put a wave down one, and if it hits a wall, it comes back out of phase. You've gotten no information there, and if you don't have a wall, it comes back, whips back in phase with itself, and it all comes back. When I think about how we're going to take the augmented virtual stuff and put it in the real world, I like to think of it like an impedance match problem. I want to just have it float in there and have none of it bounce back and have no artifacts sitting around. It should just be part of that world. So a lot of my work has been 3D displays that really feel like they're in there. It's been a whole lot of stuff to just make this immersive experience that you can't even tell the difference. Oh, forgot to do the intro. Evan Suma is also research from the lab, and he's in the audience and helped me with this, and I guess that's all done. So here I've got this impedance match platonic ideal in my mind. And then this is what I have to look at. What? This is what we're going to have? This is this perfect immersive impedance matched world? I'm trying to make sense of it. And to do that, I want to start with saying, no, reality's volumetric, damn it. So here's a light field display we did at ICT with Paul Debevec. It's spinning right now. It's being projected on a projector that's up in kilohertz rates that we did at FakeSpace. And it is spinning, so it gives you 288 views as it goes around. But that's not the important thing. The important thing is it's giving you a partial light field. It's actually giving you sort of what you would see if you were looking at a real object there. And this is what I mean by reality's volumetric. We don't want to be overlaying images in the world. We want to be putting volumetric objects in the world. And here we do a side-by-side comparison of a figurine on the right and the light field characteristics of it on the left. And it starts really looking like it's there. OK, so it's monochrome. It's got some distortion. But it's really the field that would be projected there. Even better, it's projecting light out in the world where you would start seeing shadows and stuff as if it was reflecting light. So instead of thinking of things as overlays, I want to use the word inlay from now on. So if you look at some of the work from Microsoft Research where, yeah, it's an overlay, but it becomes part of the object if you're doing it right. You're not thinking of it as an overlay through glass. You're thinking of it as part of the object or an inlay. And it's a small difference in language, but I think it really helps. I really don't like looking through glass if I'm trying to do inlays. So this is a system we did at ICT where there's no glass between you and the world. Even eyeglasses bother me in that regard. I don't want to have to look through something and pretend like this floating image here is on and accommodating on and converging on and all the other optical things I have to do on the object. So let's just put it on the object. This uses a head-mounted projector. It's this big. These microprojectors are pretty cool. And we project the image off of RetroReflective Cloth. Now the beauty of RetroReflective Cloth is that everybody, when they're looking at the cloth, sees a different image. You can play jokes on people where one person sees something gross and one person sees something sweet. They don't understand that they're both seeing different images. And what you can do with that is you can start having virtual characters really interacting with the person in the lab. So in this case, the person on the left is seeing that image on the left, which is the virtual character pointing to the person on the right. If you think about it, all classical painting, right, the eyes always look at you, and no matter where you go, they're staring at you. That doesn't do you any good for an augmented world. It's wrong. You really want eye contact to be accurate. For the Army, you really want eye contact and projected threats to be accurate. So this is a way to have viewpoint-specific imagery. And of course, you have to render it knowing where the people are and all that sort of stuff. But what I want to get across is that this is very different than thinking about just this information overlay on the world. This is really about putting something in the world. Also, just a small note, these projectors are small, and with RetroReflective Cloth, you get a whole lot of energy back. This is in daylight, in the middle of the day, just an off-the-shelf projector, and you get plenty of light back. So these overlays don't have to be put only in lab environments, and they don't have to be indoors. We really could start seeing them on phones, and I've put RetroReflective Cloth in airports for fun, and you really can do the thing where you get like a little arrow telling you where to go. So I'm talking about reality is volumetric. Sound is volumetric too. This is a simulation system we have where you sit down and you're doing officer training with a virtual character. And we tried it, and something just felt wrong. The virtual characters were his lips were moving properly, and all the animations were proper, and all the ad assets were proper, and the projector was a gorgeous projector, but it was still off. Something was wrong with the sound. Well, sound is a wave field. If you're sitting in the center and you have stereo speakers, that's fine. You'll think the sound's in the center. But there's this effect called the precedent effect, which is if you're sitting at that table but you move slightly to the left, then the sound field from the left speaker is going to hit you first. And if it does that, your brain just goes, oh, OK, it's coming from there, and then stops listening. And we want to see if this was what was causing the problem, so we did a study. And it is, especially if you don't jump over the slide. If you move between a couple different positions, we definitely found that if you're sitting right in the center, the stereo speakers are fine. But if you get off center at all, then you start localizing to the near field speaker. So the really fun way to do this is you do wave field synthesis, and you just come up with an array of speakers. And then you can go ahead and do the wave field that would be coming from that place. Now notice that's the same idea as a light field. And that's the point I want to get across, is that people are hardwired for wave fields. They're not hardwired for point sources or overlays. This is a really fun system we did, again with the spinning light field display, but it was for teleconferencing in the graphics lab at ICT. And her head is really there. Okay, it's got a lot of artifacts. Actually, the artifacts kind of make it look more high-tech. But, I mean, it is so Princess Leia with those. But her head's really there. It's not like looking at a flat screen. The only thing that's weird about it is her head's in a box. It's like this talking head in a box. But, boy, the head's pretty good. But I want to talk about the box for a second, because reality is framed. Think about old frames. They were specifically to take a painting and make it blend, to impedance match it with the wall, to make it so you realize this is its own world. And there's a whole bunch of stuff about frame design. In our minds, we can't help but frame reality. So this is a really quick mock-up we did where a virtual character walks into you, you're wearing a head-mounted display, and then he sort of threatens you. And we just record your body motion while all these things are happening. And here he sort of steps in, and he's in your space. So you step back. And then there's other squiggles you see. One is he starts reaching for his gun, and another is he stomps his foot on the ground. This is a wide 5 head-mounted display on the left, and that's the head motion in the red line. On the right side, you see the head motion when you're looking at a flat screen. And we also did this with stereo glasses, and it wasn't much different. So now what we're starting to look at is if you just cover up that little line at the bottom where the frame intersects with the ground, you buy in even more. Frames can really hurt if you don't use them right. But frames can also help. So this is a really kooky one. It's a video conferencing system. You're looking at your video window on the right, framed by the optics of your camera, and you're looking at the remote participant on the left. So your world is being mapped by the frame on the screen. So then what we do is we insert the video of a person walking up behind you. And you turn around because, well, it's in your frame, so he must be in your room. And so it's this weird example of a simple little trick where your frame is where your mind puts it, so you can use it to your advantage. And I think a lot of these mobile applications are doing it wrong and right. There's a lot of them where you have to hold your phone up and pretend like you're looking at the building out there. It's in this little picture frame, and it's the wrong size, and you have to focus closer. It's not working. There's an obvious frame there. But this is an example that won the Qualcomm AR Challenge a year or two ago, and it's turned your phone into a virtual camera. So now you're taking pictures of the virtual character, but the frame of the camera, the frame of the phone makes sense because it's a camera, so it's supposed to have a frame. And when I tried this one, that little creature guy, he just pops out. He's there because the frame is helping you. And finally, this is the most exciting thing we're doing so far in the lab. You can stretch the frame through perceptual tricks. Here, Adam Jones is a new postdoc in the lab. He came from MSU. And he found that if you just diffuse some white light at the bottom of the head mount, you can make it feel like it's a wide field of view head mount. So to prove this, he took our 150-degree wide 5 head mount, and we did distance estimation tests. And he did it with a 60-degree field of view head mount. Actually, he did a 60-degree field of view head mount, and he found this decrease in accuracy. And then he did it in the 60-degree field of view head mount, but just with an LED glowing white light down there. You don't see the world. And the results are as good or almost as good as the 150-degree head mount. This is really cool stuff. And again, it shows you that psychologically, the frames are fungible. We can stretch it. Which leads to the next point. Reality is malleable if you think about it as being in your head and what you're making out of it. We have a 40-foot by 40-foot tracking area. We would love it to be infinite tracking area. So for this test environment, we have somebody walking on an S-curve path, and the idea is that we'd love that S-curve path to be bigger than the 40-foot by 40-foot environment. The black box is our actual tracking space. It's the real world. What you see in the bottom right corner is what they're seeing in the head mount. And when they walk here, notice that the red line, which is the real world, is tighter than the green line. So Evan Suma did this work where he starts looking into perceptual illusions and how far you can push them. And this is about where you push it, where you can get away with it. So we're wrapping the person around in a figure 8 back and forth in the lab. We're making the corners a little tighter, and we're also translating the space a little bit. You'll see that when the black box starts moving a little bit here, then we're making you walk slower than you're walking in the virtual environment. But from your perspective, you're just walking around in a virtual environment. And the best part of it is for those that do experiments like this, if you keep walking around in a figure 8, then your cable wraps clockwise once and counterclockwise once and clockwise once. It's a really great trick. It's what they do with cables on boats to lay them out. Does this translate to augmented? Well, I can't say for sure, but I did this mock-up really fast, which is just taking a video and you sort of touch the object and then push the phone forward and it zooms in on the object. And there's something in there. It feels like your arm reached out and touched the object. It feels like you're warping space, the real world space. So that becomes the question. Does the real world get warped, or do we just sort of keep two models in our head, a virtual model and a real one, and we're okay with that? So to do that, we have a person, to start looking at that, we have a person lift the head mount up, point a little remote at a target in the real world and say, that's in the real world, keep track of it. Then we do the same thing where they put the head mount down and they have a virtual marker in the virtual world, and we say, keep track of the virtual marker. Then we redirect them. We do one of the spinning the people around things. Reality comes in second, pretty reliably. The people will redirect the virtual object and the real object by about the amount that they were redirected in the virtual world. This really bothered me, because I was the one that said, no, we'll always know the difference. This was not the result I expected from the test. So I do it again, and I put the head mount on, and I'm really trying to keep track of where the real world is and where the virtual world is. And what you find is that it's like that rabbit thing in the top where you can only see a rabbit or you can see a duck, but you just can't see both at once. It seems like we can only hang on to the virtual world or the real world, but it's really hard to do both at the same time. And I won't say that we warp reality really, but I will say that it's the one that seems to come in second. It's a whole lot of work to keep track of it. The way I did it was I had to constantly keep track of it relative to the virtual. It was just a head trick. So this, to me, is one of the most important things. Reality itself is toast. We can warp it, we can frame it differently, and if we look at what culture is doing with it right now, reality is kind of history. Augmentation is currently weaved into the fabric of modern reality, no matter what we do about it. Look at the information we have before we even go somewhere. And I didn't really understand this till I went and bought some linear slide rails from a guy on Craigslist. And it was an hour drive from my house, and they were heavy. And I had to get them back to the lab on the weekend. So I Bing mapped his house first, and I did the street side view because I wanted to see how I was going to load my car with it. And it's the house there on the right, and he's got this nice long driveway, and the garage is in the back, so I'll back my car up. I had it all figured out. So I drive an hour out there, and I pass by his house, and I actually missed his house, even though my little phone was telling me that was his house, because there was a car in his driveway. There was no car in the driveway of the house I looked at. And I'm sure some of you have felt this, where you look at a place first, and then you go there, and something's wrong with the real world because you saw this first. If you think about it, and it's very non-Ranazuma-ish, but just the amount of fidelity that we have online now, the resolution and the information is vying. And if you just give up the it has to be in real time, then you don't necessarily have to wear a display to at least alter reality. So we anticipate the virtual. We're tuning away from the real world all the time. These are 3 kids that got a limo ride for free. They're friends of the family. And I love this photo because 2 of them aren't in the fancy limo. They're checking out their iPhones and posting it because it isn't true unless you Facebook it. I mean, what's the use of experiencing it? Or they're playing a game because they're bored. They're in a car. So we tune away from the real world. We function better with the virtual. 75% of the people use their phones in the toilet. And I would guess that after a year of that habit, you're going to have to use the phone in the toilet. But we won't touch the real world. No way. Don't want to touch that dirty sink. We just expect it to react to us. Give a kid a hammer or a pair of pliers. We've got kids that are 2 years old learning on iPhones and learning on iPads. That's real to them, not a hammer. Really. And we prefer the virtual. A study done by John Berger up at Stanford shows that kids are now preferring MP3 sound, even though it's horrid and distorted and hurts your ears. They like it better. It's crispier sounding. So we're learning to prefer the virtual. So I'm giving up on reality. I'm giving up on augmenting it. I want to reverse the paradigm. Instead of pushing pixels out in the world, we need to be pulling the real world into our augmentations, because we're living in our augmentations all the time. And as researchers, it's a really cool way to look at it, because it's a whole bunch of new problems you can solve with all the technology you already know. Right? You already know how to do scanning. You already know how to do overlays. So just reverse this stuff and bring all that geometry into the virtual. One thing we're doing in the lab is really simple. It turns out you can detect breathing rate with the Kinect fairly simply just by looking at chest cavity volume. So you can detect breathing rate, and then you can also detect what I do all the time, the scissor knee up and down. And we're hoping that things like this allow us to start reading body language. But this is kind of a reversal. The idea for the original for the Kinect was to project out onto, not to reverse it in like this. Work by Butler at Microsoft Research is taking a light field display, but it leverages your body. Another thing that's really useful about the real world, the dexterity you have that you don't have in virtual worlds, it allows you to actually optically touch a light field. And Scott Fisher is doing work at USC for the million-story building, where a new building's going up, School of Cinematic Arts, and he's trying to tie stories in with it. So it's weird. We have to reverse this way of thinking. We have to ask ourselves, what are the affordances of reality? What is it that my phone does already that I actually need? And it's interesting to think about nouns, people, places, things, and ideas. Those seem to be the things that we can use and pull in. And the last part of the talk is reality's going mobile. So there's all this stuff going on about augmented reality now. This is the LA Times in October, and usually when my mom tells me about something, I know it's hit mainstream. So she sends me this article from the LA Times. But you know what? She sent me, actually, my mother-in-law sent me the New York Times back in 1989. Actually, Jaron, you're mentioned in this article. It was one of the first big ones for virtual reality at the time. This was my virtual reality. It was this platonic ideal that I loved. I was going to be immersed. But then the press came along and did that to it. And then, because of all that, somehow virtual reality just sort of went away. It just disappeared for a while. We all went and made money doing internet stuff. What happened? What happened was games came through, and games ate VR for lunch. Not only did they eat VR as experience for lunch, it took our lunch money too. All the good guys that were at SGI, they all went over to the Nintendo 64 project. Literally, it was the same guys. And they did the chipset that was over there on the Reality Engine, and they stuck it over there in the Nintendo 64. Games just came along and took it. And they were supposed to. So we had our hype, peak of inflated expectations, which is this dream of what VR could be. And what I'm claiming is it's also this dream of what we think AR can be. But you know what? Markets are markets. And if you want 100% market share, as Ann Balsamo says, you have to have a reason why the people want to engage with the technology. Games gave them a reason to engage with the technology. And I think Ann's here. I use that one all the time because what happens is you get up to the innovator and early adopter phase, and then it's going to peter out unless everybody has a reason they care. And games did pretty well. If you look at that 1989 article, it said maybe two people might one day play simulated tennis with each other without leaving their living room. And 17 years later, they did. They just didn't need the head mount to do it. It's still pretty fun. 80% of the value is there. So we have to figure out what it is that's going to give users a reason to engage with augmented reality. What is it? We're in this early adopter phase still for what we're thinking it is. What is it that people are actually going to use? And just like games weren't really VR, but they took it, that's what this is. It's mobile. It's not really augmented reality, but if you think about it, if you've got all your data with you, no matter where you go, and if that data is pretty high resolution and pretty high fidelity, and it's really the right stuff at the right time, and you're all incorporating in this weird cognitive world model anyways, then as much as I don't want to say that's augmented reality, as far as the market's concerned, that's working just fine, thank you. And the other thing is, not only is it mobile, but it's a probe. That may not be what it is, but they're giving that thing out, or they soon will be, to thousands of people, and they're going to find out what works. So as researchers, that's what we have to do now, because culture always wins. So you have to get a probe that gets out there into culture and teaches you something, and you've got to get it out to lots of people to do that. So the final thing we're doing in our lab is we're giving it away, because I want lots of people to do it, and these mobile devices are dirt cheap. So we have this device, which are these cardboard viewers. And you can fold them up, and then you can, it's got two halfway decent lenses, and you can slide an iPhone or a Windows phone or a Droid into it. Droid right now is the nicest because the screen's the nicest and largest. It's got a place for a camera in the back, so you can do augmented stuff with it. It's got a tracker in it. This is a world that some students did called, oh, I love this world, Minus Lab. And they just made this gorgeous 3D environment for games, and it took a couple days to just turn it into this viewer, have it stereo where you can fly around it. So we're giving these away, and it's already paying off dividends. John Carmack at E3 just presented, it's basically this, with an LCD display and a bunch of duct tape. And believe it or not, it got one of the best of E3 from the press awards, because it works. The displays are wide field of view enough, the tracking is pretty good, and you just need duct tape. It's light enough. So we're seeing what actually happens when it gets out there. Steve Finer's working with these systems using Windows phones at Columbia, and we have 5 of those cardboard things to give away today, and we have 5 for Droid phones to give away. I want to show another direction we're doing, which is really, it's a weird mashup. You take a pad viewer, you stick 2 lenses in front of it, you have a control surface. This is the work of Perry Hoberman in the lab. And he's got this whole LA Noir environment where you can turn on a flashlight. And you can't quite hear it. It's got like that kind of music in the back. It's really fun. And students can just build these worlds and try them. And it's this weird hybrid of real pad with augmented world. And I just did this so that you guys would know that, yes, it's augmented. I got things that float according to a camera in there. But it's really weird, because you reach out, and you can make the rock any size, right, depending on if you think it's small or large. So we'll give away 5 of one and 5 of the other. But also, if you go to DIYMXRLab.com, you'll get to this page. And everything is there, that you can cut these with a razor blade yourself. We tell you where to buy the things. And then really cool Perry software. It's all open sourced. It's all Unity-based. Although Steve's also got some Windows-based stuff as well, because Unity's not running yet on the Windows Phone. And you can just do it yourself. After the question session, we'll have the viewers with things running in them so you can look around and see them. And just to recap, so what are we augmenting? Which means we have to understand what reality is. It's volumetric. It's framed. It's very malleable. It's kind of toast. And it's very mobile. Thank you very much to a whole lot of people. I want to point out that ISMAR 2012 is coming up, and Blair McIntyre and Greg, who are both in the audience, are co-chairs of that. And thank all the people at USC and UNC who have helped me out. Thank you.
Thanks, Mark. All right, we're plowing through. Next up, I'd like to introduce Jaron Lein, who is a partner architect at Microsoft Research, where he leads a team that focuses on biomimetic information architecture, right? And or more simply put, I think it's using avatars to study human cognition. Jaron is most widely credited or popularized the term virtual reality or mixed reality in the early 80s, and he founded VPL Research, the first company to sell virtual reality products. In the 80s, he led the team to develop the first implementation of multi-person virtual worlds using head-mounted displays, as well as first avatars or representations of users within such systems. I think some of the kind of trivia things are Time magazine named him one of the 100 most influential people in the world. And he also has a book out that's an international bestseller. But I think without further ado, I'll let Jaron talk to you.
Hey, thanks. So, well, I hate lavaliers because my hair always whacks them. It's huge thumps. Anyway, Mark, that was great. That was really fun. I kind of disagree with a whole bunch of it, but we can talk about that in the panel. My thought about what I'm going to do with this time is actually related to a second book I just finished. So, for the most part, my technical life has been separate from my author life. So I wrote a book about philosophy of people and machines a few years ago called You're Not a Gadget. And the new one is about the future of digital economies. And I just finished it last week, so I'm still sort of a little dazed by the whole process. And the damn thing came out over 500 pages, so now we're all looking at it, trying to figure out what on earth to do to cut it back. But it relates very much to mixed reality and virtual worlds. And an entry point that I'm going to use is towards the end of Steve's talk. He mentioned the privacy issue, that in order for us to have technology on us all the time as we go about in the world, If present trends continue, it would seem to pose a problem. We're already in a situation where it seems almost daily, but certainly every week, there's some new revelation about how much data is being gathered about us through the mobile carriers or through other entities. There are all sorts of weird shadow businesses modeling all of us that we also just start to learn about gradually. And whether you feel that's a problem or not, is I suppose a personal decision. As a parent, I kind of find it a problem as related to my daughter. Now, meanwhile, there's this other thing that happened, which at first seems disconnected. And what I've done in the new book is I believe I found a bridge between the two problems and also a suggestion of a solution. So the other thing that's interesting is that around the turn of this century, we finally hit the point where computers and networking got cheap enough to really become ubiquitous. And suddenly everyone's online, everything's happening on the web. There's giant data projects of all kinds, giant collaborations being enabled for the first time. All of these things that many of us talked about for so many years and wondered if they could really happened. And then what happened was a sort of a strange result, which is a whole lot of financial trouble and a whole lot of faltering growth and a sort of a strange inability to dig out of it, and a world that seems bent on instability or austerity. And that shouldn't have happened that way. I mean, historically, when new waves of technology arrive, they usually bring with them waves of wealth. That's what's supposed to happen. And so I became really interested in that. Is it just that we haven't seen the benefit from our works yet? Or is it that it would have been much worse if we hadn't done what we'd done with networking? How do we explain all this? Or was the whole world just, headed into such a horrible direction that nothing could be done, and just be fatalistic about it? So I've come to believe that what happened was a sort of a particular way of thinking about digital systems in the world that doesn't turn out to work very well. So in order to explain that, and then I will bring it back to mixed reality and the privacy issue in just a second, but you have to bear with me for a moment. So let's consider two kinds of information systems. One of them is much older than the other. The old one is an economy or market, capitalism. So that's an information system. And an interesting thing about that information system is it's made of people, each of whom are players in it, and each of whom takes on some risk in order to do whatever they do to run their business or run their lives. And then they also accrue some benefits. And this is the way markets work in capitalism. Now let's put that aside and let's look at this other thing, which is the computer, the thing that was defined by Turing and von Neumann and Claude Shannon that we all make our livings studying. So what a computer does is it says, we're going to create this little box within reality, and within this box, we're going to be able to create a sort of an illusion of an altered kind of reality in which entropy doesn't exist. Everything's deterministic. It follows these rules, and all the entropy, all the waste heat gets dumped over to the side. So it's this very special little box. And of course, it can't last forever. No computer can be perfect. And there can be some quibbles with my definition. You could have a reversible computer and all that sort of stuff, but just bear with me in the gross picture. Am I making sense that that definition of a computer works for everybody? Okay. All right. So the thing is, when computer networking became available and cheap, people looked at it, and there's this sort of very obvious thing to do, which is to say, well, let's make markets like a computer. So if you set up a market like a computer, what you do is you try to build a system in which you make it more deterministic, and you calculate a way to throw the heat to the side, to throw the risk to the side, and to make a system that is a sort of an illusion of an entropy-free local area within which your business operates. Now that might sound a little abstract, but let me give you some examples. When we operate modern financial systems, like bundled derivatives or high-frequency trading or all sorts of things like that, what we do is we use a computer network to gather more data than anybody else, calculate an ideal result for ourselves, and arbitrage the risk off to people to the side. So it follows in a very rough sense, the general idea of what a computer is, which is a human construction. Similarly, a lot of the consumer-facing internet businesses run in a similar way, with a social network or a search business. And here, obviously, Microsoft has one of those. But what you do is you say, there are all these people who are interacting, and we will calculate within this data a way to leverage the results of those interactions to our favor, to find some way that we benefit from it, but all the risks of what those people actually do radiate towards them. We minimize our own risk for whatever happens. So many, many examples of that abound. Let's say if there's some bad thing happens because of an ad on Craigslist, it's not Craigslist's fault. Or some copyright violation is posted to YouTube, it's not YouTube's fault. Very similar to if there's a bad bundle derivative in some fund, it's not the fund's fault. It's always someone else's. Someone else holds the bag. Okay, so the reason I'm talking about this is that this all happens to relate historically to the information must be free idea, which comes from a completely different. So there was one sort of top-down thing that happened, which is financiers and entrepreneurs looked at cheap networking and said, wow, we can turn the world into a computer, basically, that calculates good results for us. But then at the same time, kind of hacker, anarchistic, wild, democratic people looked at it and said, well, information wants to be free. And the weird thing is that those two goals technically are identical. They just fit in together. The people who want the information to be free are exactly the people who are accepting the risk for somebody else's weird computer-like scheme in finance, if you see what I mean. I hope you do. I hope this is all making sense. It's very new to me since I just learned to express it myself. Anyway, here's how this all relates to the future of privacy. Because we've adopted to this world where we think of information as this cost-free thing, and we think of the job of business on the internet as being calculating the ideal result for somebody who's operating a particular, I call them master servers, but a very meta server that's calculating a benefit from the world. Because of that, the information to violate people's privacy has no cost. The idea is that if you have your phone, your position information is measured. And let's remember, if we are going to have augmented reality out in the world, and there's this question about whether we want that, and Mark brought up some interesting points about it, but let's suppose you do have the registration and you have the measurement of the person's own body motions and their state of perception in order to present them with an illusion. The amount of data gathered is profound. A profound amount of data about a person is necessary to create a well-registered mixed reality experience out in the world. So if all of that can be gathered at no cost by some central server in order to make money by third parties who want to manipulate the person or make bets about the person or whatever it is, then there'll be absolutely no boundary to the amount of privacy violation that'll happen. But the interesting thing about that is that that privacy violation is one in the same as the idea that the information wants to be free in the first place. And that brings with it this other side effect, which then gets back to the reason why I think we've had financial troubles, or at least why we haven't done enough to prevent them. And this is so simple. If you go back to as far as you like in the timeline of technology development, there's always been this Luddite problem, which is when a new technology comes along, it can throw people who were trained on the previous technology out of work. So that, the Luddites were people who were used to one kind of manufactured cloth process, and then they were being thrown out of work by better machining. So the reason that process hasn't destroyed employment as technology's gotten better is incredibly simple and obvious, which is that new technology created new jobs. So there'd be this churn. However, if we're approaching a really different phase when a lot of information technologies are becoming advanced enough that we have a choice of thinking of them as not needing people so much. And that's really a choice. And I'll get to why in just a second. But we've seen demonstrations of self-driving vehicles. Many of us are enthusiastic about research in 3D printers and fabrication. If you looked at Steve's video of augmented assembly, you can immediately see how a lesser skilled person could start to repair something, and that could lead to a loss of jobs for people who are more skilled. So you start to see information technology getting advanced enough to undo this old process of new jobs showing up. So here's an example of, let's say, an alternate world that might make that more clear. Let's suppose we lived in a world in which people were paid for any information taken off them at all. If there was just this idea that if there's any information that wouldn't exist if it weren't for your existence, you have a commercial interest in it, period. Whether it's measured by sensors, whether you entered it manually, whether it was measured by somebody else's sensor or your sensor, if your existence results in information that goes into somebody else's cloud business, finance, social network, it doesn't matter, you're owed money for it. So one way that could play out, I'll use just one example. Both Google and Microsoft are doing machine translation now, where we translate between natural languages. Now, in every single case, what's turned out to work with AI is a big data approach. The old dream of having the magic little algorithm that could translate between English and Spanish or recognize objects in the world never panned out. And instead, we use these huge corpora from the world in order to do it. So in the case of languages, there was an initial body of examples of translating between English and Spanish or such things. And this is mined through correlation in order to produce new translations that make use of the earlier examples. So in a world in which information was always paid, those original translators and ongoing people who perform good translations would get micropayments. Now, the fact that they don't now, the fact that we're treating the information as something that's free is precisely what makes spying into a zero-cost endeavor, which is why it's unbounded, which is why a plugin like Ghostery now has to block over 1,000 trackers, 1,000 in a browser, which is just astonishing to me. So if we go back in the history of networking, we talked a little bit about Ivan Sutherland and Doug Engelbart. There was another character in the same period who's Ted Nelson, who was goofy. Andy Van Damme used to hang out with him. And which one of you is the straight man? Andy was the straight man. And so Ted was the first person to propose a hypermedia, hypertext. The HT from HTML was Ted's coinage. And his original idea was to create a new form of commerce where there'd be a universal micropayment system where anybody who did stuff that was referenced would, in a graceful, automatic way, receive micropayments from other people who used it. Instead of through a lugubrious special case copyright system or something, there would just be this general assumption that any data that's put out there would be monetized. So the really interesting possibility, I believe, is that if we could find our way back to that, and I believe we can, although it's a trick how to do it. That's why my book got so large. But if we could find our way back to it, then we would have a situation where in order for somebody to gather data, they'd have to pay for it. Now, the goal is not to prevent data gathering, far from it. The idea is that if somebody pays to gather data from you as you're walking down the street using your mixed reality, and they're gathering everything about your heart rate and the micromotions of your body and who you're with and everything. In order for them to make a penny, they have to do a value add that somebody wants to buy, like you. And if somebody else wants, if it's not you and somebody else wants to buy it, you make some of the money. So you're a partner. And the in an ideal market, it should, my argument anyway, is that the cost of data should be it should settle approximately at the point where it costs just enough that if you don't do a value add, you can't make any money from gathering it. So this sort of crazy world of speculation where everybody's trying to be the most meta spy agency would simply get shut down. But beyond that, there's a bigger point, which is that when new technology comes along, what you hope is that the financial world expands. And what new technology should create new wealth. New wealth should mean that there's more wealth in the world, and there should be a bigger financial world. Because we've been demonetizing things like crazy in order to support this sort of friction-free, entropy-free illusion of the way we're doing networking, we're shrinking the financial world. Every time we demonetize a market, we actually shrink the financial world instead of grow it. And so far, the ones that have been shrunk are mostly creative things like the music business, which I used to be in also. which is down to something like a half of what it was to a third. And it looks on course to maybe go to a tenth. And now it's starting to happen to books. It'll happen to movies. All that, and of course, newspapers is another big one. But that stuff's small potatoes. The really big stuff is manufacturing, transportation, energy. But it's going to hit all of those things. All of those things are going to be hit in exactly the same way as everything becomes more information-driven. So by valuing information economy, you can have an information economy mean a richer world instead of a poorer world. It's almost tautological. But as applied to mixed reality, I think, this question of how many decades does it take for things to come about? I'm just going to sort of play out a future fantasy here. Let's say a move to an information economy that's sustainable instead of one that's swallowing it itself might take 30 years. So in 30 years, I think I can imagine that I could say why I think that, but that's a guess about how long a transformation might take. Certainly in 30 years, if we haven't fixed the instrumentation and software and latency problems and all that with mixed reality, we're not doing our job, right? And look at the people in here. I'm sure we can do that, right? So, so I think it's conceivable to imagine a world of monetized information in which you can use mixed reality and it's not creepy. I do really, really worry, if I may say so, when I see my good old friend Sergey up there wearing that thing, I do really, really worry about the creepiness factor of a whole lot of mobile sensors and devices on a network if we continue to do things the way we are. So I guess that should do it for the talk. I hope that made sense. And then I can argue with Mark.
Thank you.
So are we sitting?
All right. I think we have about 7 minutes left, but it's okay. We have three very controversial, or maybe not so controversial points. There's a pro glasses and head-worn display point. There's a reality is toast point. And we should all get paid for every bit of information that we give out, which I think are pretty interesting controversial topics. At this point, what I would like to do is just make sure that we get everybody all the speakers up here. And then I would really like to just open the floor to the audience, to you guys, to actually look at, and ask some of the questions if you guys have any. We don't have much time, but I think a couple questions. I think some of the folks who have to answer questions might get a little prize over here. I've seen Mark has a couple of them over there. So
are you guys going to have mics?
Sure, I'll bring some mics.
Great.
There's also a movable mic over here. Anybody?
Or you go? Okay, here.
Sure. I don't know how to turn this one on.
I bet I was going to sit.
Oh, it's all right. It's all right. Anybody? Oh yeah, here. There's a mic right there.
Magic. Wow,
Here.
almost like augmented reality. Thanks a lot for your perspectives. It was great, and I really appreciate the reach back toward the historical perspectives. I'm struck by the fact that there were a number of real-world applications that you were talking about. Especially, I'm an architectural historian, and so seeing Mark, what you're doing at Columbia, I was very interested to see what you're doing in terms of building footprints and kind of, I guess, a set of content areas that could be very useful for non-technologists, non-lab settings. What kinds of things are you looking at to bring some of these technologies out into other realms, out into, say, architecture or urban planning, or what kinds of possibilities might there be for taking these technologies and bringing them to a different group of people who might apply them differently so that maybe the possibilities of AR might stretch? Are there any initiatives in your labs at either Columbia or USC or really anywhere else that might be doing this?
Let's see. I can put my microphone on over here. So I have been working for many years now with folks in a variety of different disciplines, including people in civil engineering, more recently with people who are urban planners and urban designers, in trying to work on potential applications of admittedly technologies that are not quite ready for prime time. So the answer is absolutely, and I personally find it very exciting to work with really bright people who know stuff about fields that I have, the most incredibly cursory and passing knowledge of, and who can provide that kind of expertise.
My take on it is it's kind of done now. There's a There's a toolkit called Unity 3D that my 14-year-old programs in all the time. You can stick it in this phone. You got to do a little trickery to get the augmented stuff there. You got to talk to Steve to figure out how to line it up. But it's really not that hard. So it's there, and a phone will do it. We've really crossed a transition point where I don't think that's the problem of the technologists anymore. That's the problem of the culture, to start using it for things. And our problem's here to do other things with the technology.
Oh boy, there are a bunch of other apps that didn't come up in the session that various ones of us have played with. I can mention a couple of them. We don't have Adrian Chiok here, do we? He didn't make it. One of the other AR people from the old time is Adrian, who's in Japan mostly these days, but he and I worked in Singapore together, and we played around with combining mixed reality with literature, and the way that would work is you'd have an urban treasure hunt where you'd find portions of a story in different places, and so it would be sort of a combined walking tour sort of fiction experience. And sometimes it would have animations combined. And there's a lot of room for culture and art that's not traditional gaming that can come about. Let's see, we covered medicine and architecture, and I feel like there's some big ones missing. There's been some work on urban safety. So the way that works is you get a database of accident statistics, and then you're walking around and you see where have people tripped, where have people been hurt, where have there been mishaps, as a tool for trying to understand planning. That was another experiment in Singapore. There are a lot of other. That's a sampling. Yeah.
Roll Vertical, Queen's University. My question is for Mark and Jaron, I guess. Jaron, you were going to argue with Mark. I'm going to argue with Mark that nothing really can surpass reality. Nothing can really surpass reality. There's a lot of information in virtual reality that can augment reality. But just to give one example of the problem with what you stated, that reality is toast, is haptic experiences. Right? The way we interact with the world through touch and force feedback and things like that are still a big problem in augmented reality and also in virtual reality, I guess. Do you have any answer for that? And don't you think that there's a place for real displays that are maybe shaped according to objects in real reality to instead of a sort of projected reality?
So two things. One is haptics is one of the things I said is something that's useful from reality that we can still preserve and bring into virtual environments and mixed reality environments. I'm not saying this is the way I want it to go. I'm saying this is the way it's going. Kids don't have... This piece of paper is 5 to 6 thousandths of an inch thick. Okay, I know that because I've worked in a machine shop. And you can go get a micrometer and test me, and I bet you I'm right. Kids can't do that. They don't have haptic anymore. They don't even have dexterity anymore. They're literally growing up doing this.
But should we just put them in a wheelchair then?
And doing this. So what I'm saying is, it'd be great if we could get that reality, but instead of pretending like we're augmenting it, we got to reverse it. If we want to preserve reality, we have to get it back into things they're using.
So I want to put forward a hypothesis here. So I spend a lot of time with undergraduates like you both do, but also younger kids, mostly because I've been a parent. And what I think might be going on, it's too early to say, is we might have created a lost generation of sort of slightly cognitively disabled people who were fascinated by the early crappy gadgets we foisted on them. But what I'm seeing in younger kids is actually a very different and more refined sense of discrimination about technology. So like 17-year-olds are like, oh, I put it on Facebook, and I like all this stuff, and you want to shoot yourself. But then you talk to 14-year-olds, and they're like, oh, all those old kids are so stupid with their Facebook, you know. And there's like a, you know, the generational churn continues. It's not over just because of one decade of idiocy. It continues. I'm sorry, I shouldn't. I actually shouldn't. I try to only rat on whatever company I'm at, so I should rat on Microsoft stuff, but we don't have a social network. But anyway, well, I guess Yammer.
Yeah, we do now.
Yeah, Yammer. Yeah. I'm on Yammer. Anyway, okay, see, I did it. But I just think, I would say, don't give up on them yet, because the story isn't over. And I can really imagine, like 20 or 30 years from now, there's going to be this known millennial syndrome, which is people with diminished cognitive capacities in various areas.
Do you think they'll...
No, seriously, who grew up on iPhones and stuff.
Do you think they'll be able to do longhand writing?
No. I'm willing to give up longhand writing. I'm not willing to give up...
So are you willing to give up that kind of dexterity?
No, that's what I was going to say. So I'm not willing to give up the stylus. I am willing to give up longhand writing. And I think... there's a really difficult thing, which is...
the stylus is like 100 times less accurate than this pen.
Not the stylus that they're going to use once we're no longer disabling kids. So it's up to you and I to make a better stylus. I mean, the thing to do, like, this is our problem. Like, it's our fault.
I'm agreeing.
Yeah,
We have to take what's good about reality and find a way to bring it back.
Right. But so, okay, all right. But but the thing is, you know, you have to find this very difficult to find line between just being an old fart and trying to have standards. And so, to me, like demanding that kids still can write in cursive maybe is on the old fart side, I'm not sure. But demanding that they keep manual dexterity instead of having a multi-touch sensor level of reference, that's standards. That's not old fartism. I think that's fundamental.
Steve has been trying
Sorry.
to
Okay.
say a couple more words.
If you've ever watched a world champion gamer play and watch how fast their interactions are with the devices that they're using, I don't think you would say that people are losing dexterity.
I would agree.
Well, there's a point there.
Another point is that, for example, my 12-year-old lives in a household in which there is an Xbox 360, there's a Wii, and he's learning how to juggle. And that's not on the Xbox or the Wii. He's juggling balls and he's juggling rings, and that's what he finds really exciting.
And you have not made an augmented system to teach him how to juggle yet?
He didn't need it.
You call yourself a scientist?
He learned very quickly with real balls and real rings. So.
When I was 21, I made a pact with another guy at VPL Research, the little company we had, that if we ever had children, we'd raise them in virtual reality in 4-dimensional spaces to see. And then I actually had my daughter, and like, no, this is not going to happen. I can't do it to her.
But it is happening. So mind you, I feel really strongly that we're losing some abilities to think because we're disassociating ourselves from our body. And I feel strongly that you can't think without your body, which most professors won't necessarily agree with. But the body is critical to thinking. And I think we're shutting it down. So I'm not happy about this. But the spaces they create, it may not be 4-dimensional in terms of geometric 4-dimensional, but they're in n-dimensional spaces right now with new social information, with new augmented information. It is a much stronger environment. They can't let those tools go.
Mm-hmm. Well, they
think differently.
Right, and so there'll be better tools. We'll have, I mean, there was I don't know if it's public, but there's a wonderful MSR research thing from the last year showing the degree to which people can discriminate manual input on a touch screen. And like, we're not even remotely connecting with the haptic system right now.
I agree. There's a bunch you can do with haptics would be great.
We're not even, no, but I mean, all of our devices are like treating, even though it's better than Doug's old initial mouse, we're still using extraordinarily crude devices compared to what the human organism was evolved for, right?
Agreed.
And so, but at some point we ought to be able to make those decent. And at that point, the generations who grew up with the crappy stuff will be seen as being weirdly disabled. There'll be some term for it, and there'll be all these people who make a living, you know, trying to give them therapy.
Look at the generations that grew up with CGA, right, preceding VGA, EGA, right, really low resolution. And nowadays, we got to the point where we do have displays that are essentially at resolutions that are better than that of many print media.
The point I'm making is that the world is altered, that reality is more than just the physical reality. When I look at the Google Map view or the Bing Map view of that person's house and I go there, my interpretation of the house is different than if I had never seen that map view. It has altered the real world. So I'm not saying reality is going away, but I mean, reality toast is supposed to be provocative. But what I have said is that reality is permanently altered now. And I don't.
Are you saying it's like crappy white bread or a beautiful brioche? Like
I don't know what that means.
Oh, it's a fancy.
I don't know what your question
At
is.
this point, I think we're really over time. So I encourage everybody in the audience, or at least interested folks, to come up and ask the speakers directly. But this debate, I think, can go on for much longer than we have the time for. So thank you so much for participating. I want to thank our speakers one more time. And enjoy the rest of the Faculty Summit.